How's it going, everybody? Andrew Robinson back at it here with another Max MSP tutorial. It has been a second since my last video, and I apologize for that. Just some in real life work stuff got pretty crazy busy, but I have a moment now, and it is time. We are back, and we are going to do a roundup on our intro to beginner Max videos. I have made several different pathways of these learning modules for Max MSP. We've talked about the absolute most basic beginner objects, things you will use in Max to do literally everything, and different ways that can be done. We've talked about jitter and the visual side of Max MSP, and we've talked about audio and like the signal data side of Max MSP. And in this video, I want to take all of these concepts we've talked about so far and wrap them all up into one cohesive multimedia project that demonstrates, the basicness of these ideas and how you can swap them out for a few other objects we've talked about to really create whatever aesthetic you want to go for. And as long as you understand that, how these objects work together, what, the end result is when you do certain things with them, even if you don't understand the technical side in the nitty-gritty detail, as long as you understand what is happening in the patch and you like it, then that is good to go for. So with that, we're going to just jump right into this project. And first, we're going to start with the visual side of things. And the first thing I always do anytime we do anything with visuals is we need to create a jit.world, which is going to give us this nice window for us to see things in. And I also always like to say at floating 1, so that window doesn't disappear when I click off of it like it just did, at FSA1, which stands for full screen anti-aliasing, which means it'll look nice and sharp when we go full screen, and FS menu bar 0, which will hide the menu bar when we also go full screen. Very important, always basic things I like to have in my jit.world. Then we're just going to create a toggle, which I did by pressing T, patch it into the jit.world, lock our patch, which you can do on a Mac computer by holding down Command, clicking anywhere in the blank space. If you can't figure out that shortcut, just click this lock icon down here so it's locked. Then we can click on our toggle. We can do the same thing to unlock our patch, and you notice the background went from black to gray, which means it's rendering now. And again, this is stuff we've all talked about in that intro to jit.world video. And so now that we have a rendering jitter world that we can see things in, we just need to create a video plane that's going to host the video information in this 3D world. And if we say at transform reset 2, it's going to stretch to the edge of the window, thus taking up the whole screen, and we can view any kind of 2D animation now in this window pretty easily. So let's send it some kind of animation. We talked about jit.noise in our intro to procedural animation. I'm going to kind of do the same effect there. We're going to start jit.noise for char, 4 planes of data, char data type, 3x3 matrix. So we'll have 3x pixels and 3y pixels. And if we just patch that into the video plane, press B to create a button, patch that into the jit.noise, click it, we're going to send a random values across our RGB plane spectrum, and that's going to create random blocks of color. Now, here's a key thing to point out. It's blurred. And the reason that is because jit.noise is a matrix, jit.gl video plane is an OpenGL texture, and these are slightly different. They're both dealing with visual stuff in Max, but slightly different in their functionality. And again, something we've talked about in our intro jitter series, so I'm not going to go too much over it, but just know matrices can go to textures, not so easy to go back down to matrices. And so when you send a matrix to a texture, it will do this interpolation on the effect if it doesn't match the dimension size. And we only have a 3x3 pixel matrix here. So yeah, it's upscaling it a lot. And if we want to get rid of this, if we want just the normal blocks of color that you would expect with jit.noise, we can do this trick, which is creating jit.matrix. We're going to say 4 char, we're going to say 640 by 480, so we upscale it ourselves. We'll patch that jit.noise right into that jit.matrix, click that button again, and now because we ourselves are upscaling it to a pretty large dimension size for jit.world, which 640 by 480 is the size of this window, we are now getting these solid blocks of color with pretty much no interpolation. There's probably still some because this is half the internal dimension size, but it's not noticeable. So this is totally fine. And now we have these solid blocks of color, and every time we click this bang, we'll get new blocks of color. Now, if we wanted to change the number of blocks, we can do that using messages, which again, we talked about in our absolute basic intro video. And if we just send the message dim to jit.noise with the variable $1, $1, which will allow us to change the dimension size. $1 is a variable. So if we create a number box, patch that in here, change this number to whatever, let's say 20, That 20 is going to come through this patch cord. This dim is going to see that data. It's going to change this $1 with whatever this number is, and then output that message. So it's now dim 2020. Because these are both $1, it's looking at just this number. If we sent a list and we wanted to change each variable independently, we would have to do $1, $2, and I'll show that in just a second. But now that we've changed the dimension size, I just changed it to 15. We're going to click bang, and now we have a new set of squares. We have 15 across the X, 15 down the Y, and everywhere in between. And you could get crazy with this. You could do 264 by 264. That's 264 pixels now in our X and 264 in our Y. And so that's pretty much how you do that. Now, if you don't want to click and draw new cells every single time, if you just want that to be automatic, we can use this message box. We could put a comma in here and then say bang, and that's going to make this two separate messages. Technically, you use the comma to separate messages internally inside one message box. So what's going to happen now is we're going to change the dimension size. That's going to do that same thing of sending the dim, whatever this number is, to our jit.noise, and then it's going to follow it up by a bang message, which is pretty much the exact same thing as clicking this bang button. So now we can do this. We can type in 10. There we go. We have 10. We could drag up to 38. There we go. We have 38 by 38 now. And anytime I change this, it's going to change the size of the numbers of pixels we're drawing. So that's pretty cool. And now we just got to figure out a fun way to mix this in with what's going on. Let's bring in another matrix effect. Let's use the jit.grab object, which I haven't talked about specifically in a video, but what jit.grab does is it just grabs your external webcam data. So if you have a built-in webcam, it's going to grab that by default, and we can just send the open message to jit.grab, click it, and that's going to turn your webcam on. If you are following along at home, your webcam light may have just turned on, as is pretty customary. And then we're going to use a jit.add object, and we're going to add our cell noise matrix to the values of our webcam. And that is going to, well, first it's not going to work unless we change this dimension size. And the reason for that actually is because, like we've talked about in the jitter videos, it needs a bang to output a new frame. And because there's no bangs happening here, unless we change this number, it's not outputting its frame. So there's two ways we can fix this. One, we could literally just change the order of operations of these patch cords. Because the jit.grab is now going into the left inlet, this is the hot inlet, which is a concept we've talked about. And this is constantly outputting frames because it's tied to our jit.world render. Then it is constantly outputting frames, and so we are getting that update of this being, of every new webcam frame being added to whatever our cell noise value is. If you didn't want to do it that way, for whatever reason, you could also just send a render bang from this jit.world outlet to the jit.matrix, and then it's the same thing. This matrix is just a buffer, so it's holding whatever internal matrix we store in it, which is this jit.noise, random cell values, and that's stored in here, and then we're just sending a bang to that matrix to constantly output. So either way, it's totally fine for this to work. It's kind of whatever makes more sense for your project. And you can see when we actually add these together, it's pretty washed out, and that's because we are literally adding the cell values, the RGB cell values of the webcam to the RGB cell values of our matrix. And if it goes to 1 in any of those channels, the RGB, or past 1, it's going to be completely white and like look pretty washed out. So we can use other JIT binary objects to kind of change the aesthetic and the look of that. If we tried multiplying the cell values, we're going to get this, which is a lot darker in tone, and that's pretty interesting. And again, this is totally a fine way to do that. And there's so many jitter operations we can do. We could do absolute difference, which is going to subtract them and then give us positive values if they return negative, which creates this cool like mixed normal negative feedback looking effect. So that's like pretty interesting. I'm going to leave it with that. But we could do other things too, potentially. I just want to show. Let's do Crossfade. And now we are currently all the way faded to the left. So if we just hard code in here at the Xfade attribute rather than setting up a message, both of these are totally okay ways of doing it. This is what it looks like cross-fade. Yeah, and I don't like that as much. So let's go back to the jit.abs diff. That looks way cooler in my opinion. Maybe we could do like the jit.xfade idea after. I don't know. Again, this is all experimentation and kind of just doing whatever you think looks really cool. So I'm just messing with different ideas right now. And that's not as interesting. Maybe if we did like an 80-20 kind of deal, mostly our negative feedback, a little bit more of the regular webcam. So it's just like highlighting colors a little bit more. That's kind of my thinking behind this right now. And yeah, I'm cool with that. We can try slightly more, see how that looks. Yeah, I don't like that as much. We're gonna leave it with the 0.2. And that's pretty much jitter and setting up basic effects. But say we wanted to make this interactive. There's a lot of different ways we could do that, and that is one of the super coolest things about Max MSP is literally just making effects interactive. So if we wanted to try to add some kind of interactivity into this, we could do a technique I talked about in another intro video. And that is using motion differencing values to trigger events. And it's a really easy concept to do as a beginner. What we need to do is we need to find the differences between our current frame and the previous frame of our webcam data. And that's pretty easy. We're going to use the trigger object to do that. And we're going to say TLL. And we're going to patch our jit.grab into this. And you can think of the jitter matrix as technically a list of a bunch of cell values. For trigger, it totally works that way. And basically, it's going to output our current frame from this inlet and our previous frame from this inlet, because trigger does things in sequential order. So this is current, previous. And all we have to do is subtract them from each other. So we're going to use the jit.abs diff value again, subtract those from each other, and then if we patch this into our video playing effect real quick, we'll see this is what it looks like. And this is already a really cool aesthetic just in and of itself before even extrapolating any kind of important data information from that. This just looks cool, but you notice it's also kind of stuttery, and the reason for that is because sometimes we're passing frames through so much that some of them are duplicates. And when you subtract a duplicate frame from a duplicate frame, everything is the exact same across the board, so you're going to get a completely all black pixels for every frame for that frame. And if you don't want that, if you don't want that stuttery effect, then we just have to remove the duplicate frames, which we can do using the jit.change object. So if we patch the jit.grab into that and then patch jit.change out to our trigger object, we've removed those duplicate frames, and now we are no longer stuttering because we're no longer subtracting duplicate frames from themselves, basically. And so that's kind of more stable, cool aesthetic with this effect, and you can see all the edges and lines of my face really well with it. But that's not what we're here for. We are actually going to now add in a jit.rgb to Luma, which is going to take our 4-plane matrix alpha RGB and convert it down to a 1-plane matrix, which will make it black and white. But this is also going to make it easier to extrapolate the motion data from what's happening in this video. And we can do that now using the jit.3m object. And if we patch our jit.abs diff object into that 3m and then patch the middle-ish output of jit.3m, the mean one, which gives us the average values of all the cells, into a float number box, you'll see it starts updating right away. And this is adding up all the cells in this window and returning the average value of that. So if I'm not moving, you can still kind of see the outlines of my face and body and things. And that's averaging out to about a value of 4. But if I move really fast, there's a lot more white pixels showing up in the video, right? And so therefore, we're adding more pixels into our average, and we are getting a higher value. So it's literally the average of all of these pixel values is the amount of motion we are creating when we move. So you can measure motion through this technique by adding up all those pixel values and then mapping this value into something else. So we can do that to kind of create a lot of weird, crazy effects if we wanted to. So we're going to patch our video playing back to our Xfade object that had the random cell noise and our webcam frame data in it. And I don't know, let's just scale our range of values from like 0 to 20. I don't know what they really are. Even though we aren't looking at the motion in the video plane, the math and the objects are still performing their function, so we can still see motion here in that number box. And when I move a lot, it's like it doesn't seem to go above 30. So we'll set 30 to our max input scale range, 0 to 30, and we'll scale it out to be something like 3 to 30. I don't know. I'm just experimenting. But if we plug this float number box into that scale, we're going to get a new range of numbers out of the output, which, I don't know, let's just patch into this number box to change our dimension size. So now the more motion there is, the more cells of random noise we should be getting. And that's pretty cool. It's pretty fast and frequent, and that might be an issue, kind of depending on your interests. So there's a lot of different ways we could handle this. We could say, we could kind of create a fake gate, as I like to call it, and we're going to do that using our binary operation. So I'm going to give myself space, and we're going to say if our motion value is equal to or greater than something that is like actually significant amount of motion, we'll say 15 to start, then it's going to return a 0 or a 1 out of this outlet. 0 being false, meaning if this value is not greater than 15, and a 1 if it's true, meaning that this value is greater than 15. And we can then use simple rules of multiplication. If we multiply a value by 0, we get a return of 0. And if we multiply a value by 1, we get a return of whatever the value is. So now, this patch cord, if we take our motion value and we multiply it by the 0 or 1 that will come out of this outlet, then we will get a 0 through this patch cord if it is less than 15, but if it's greater than 15, we're going to get whatever that motion value is, which is pretty cool. What I wanted to change was something like this. We'll do a slightly smaller number on our output scale range, and I don't like that actually. We'll double it. So we'll do 20, not 30, not 10, we'll do 20. And now when there's motion, you see there are a lot of cells popping in. Now this still may be changing too fast for potential interest, and that's because we are constantly outputting a number through this patch cord, which is going into this message, updating, and then also constantly sending out a bang. So that's actually causing some issues with how I want the order of operations to work in this patch. So actually, I just thought of an easier way as I was explaining that. We could actually just put a change into this patch cord right here, which change does the same thing as jit.change. It's just going to filter out duplicates. So if this is a 3, it's not going to pass out another 3 unless it changes to something else first. So now that it's constantly sitting at 3, it's only letting that first 3 through to actually give us this 3. And now if I move, we'll still get some kind of drawing of random values. And this kind of is interesting because it creates a new aesthetic. Like, it only draws new stuff when I am moving. And, I don't know, let's increase this something to crazy now. Let's do 100. So it looks more like it's like glitching out for a second when I move, which is pretty cool. I don't know, I guess. Like, that's interesting to me. Maybe it would look even cooler if we actually increase this X-fade value now. And this is kind of what I was trying to talk about at the very, very beginning. A lot of this stuff is just knowing kind of what does what, and then tweaking minor parameters of those objects to kind of get a full effect for what you're really trying to go for. And there are so many different ways to do that. It all kind of just depends on what you want. So now that we have this working, let's add some audio into it, shall we? Let's do some audio effects. When we talked about the cycle object, which just creates a sine wave at whatever frequency you set it to, and we can actually use this to do a lot of cool music synthesizer type stuff. If we create an easy DAC, which is easy DAC tilde, that's going to be our audio output, which is essentially our speaker. And any sound we send to our speaker object will actually come out of the speakers. You notice it's grayed out right now. That's because we got a locker patch, click it, turn it on, and that turns the audio driver on, and now it is ready to output sound to the speakers. And once we give this a frequency value, which we'll just patch a float number box in for a second and put in a random value like 220, which I know is an A note. It is now generating a sine wave at that frequency, which is the equivalent of hearing the A pitch on like a musical instrument. So this is kind of cool. It's got a really interesting effect, like literally already, just this one note drone. It really makes it feel like this is supposed to be creepy and glitchy when I am experiencing this, and that's just already really interesting to me. But let's make it fancier. Let's say if this, if this is greater than 15, since this is what we're using as our threshold, let's just pick a new random value. And it's actually way easier to think about specific notes values if you're doing MIDI stuff, at least to start with. And we're also going to turn the volume down on our master audio gain in the bottom right corner for just a second so that it doesn't get in the way of me explaining things. And we created a K-slider object, which is a graphical object that shows the keyboard. And if we patch its outlet into the right cold inlet of the message, it's going to display what is coming out of that patch cord. And if I click the lowest note, the lowest C on this keyboard, it outputs 36. So this 36 is the MIDI value for this note. And if I click this one, which is our highest, it's 83. So that is this highest note on the keyboard and the MIDI equivalent thereof. So if we wanted to create a range of notes to potentially play in between, that is all possible notes on this keyboard and everything in between, then we just need to find that range of numbers between 83 and 36. So let's do some basic math. 83 minus 36, and we'll patch that into the left inlet, and then we'll patch our output to our right inlet of our message box. And now when we click this message, it's going to do the math. So that 83 minus 36 is 47. So that's going to be super important to remember, because now we're going to create a random object, and we're going to say 47, which is going to give us 47 random notes from 0 to 46. It's one less than what you define in the random, because 0 counts as one of those random numbers. So even though the max is 46, because we're including 0, that's still 47 random numbers. And if we just add 36 to our random output, so we'll patch the output cable of random into our 36 object, add 36. Now we're just adding 36 to whatever random value is coming out. So when it outputs a 0, we're going to add 36 to that, and it'll be 36. So that will actually then be our lowest value. And if it happens to output its highest value, 47 or 46, we're adding 36 to that. So that's going to actually be 82. And if we want to hit that 83, let's just increase 48 to, let's increase the random to 48. So that means now the highest value it could possibly output is 47. We're adding 36 to that. That'll give us 83. And then once we have that, we can actually see this work really easily if we just attach it into, again, the right inlet of a message box, which will always display information. We'll send it a bang to output its random function, and we will see we are getting those notes. We can even patch this into the K-slider itself. And then when we click this button, we'll see that it is showing the note that it is playing on that K-slider, which is pretty cool. And this is kind of the MIDI values in a nutshell in Max MSP. But we have this super cool object called M2F, which converts a MIDI note number to a frequency, which is perfect if you want to take MIDI and use it to drive a cycle object like we are about to do. So now every time I hit bang, it's picking a new MIDI number, and this is converting it to the equivalent frequency value to hear that pitch. So super cool. Let's turn our audio back up so we can hear this in action. Every time I hit this button, we get a new note. It's kind of a cool, lo-fi, old school sequencer. Kinda. in a way. You could definitely think about it that way. So let's say every time this glitch is out, it plays a new note. What if we did that? That would be pretty cool. And we can do that really easily already with everything we have set up. We just need to take this threshold value of being greater than 15, and we're going to say cell 1. So that way, when it outputs a 1, this cell 1 is going to look at that 1, and it's going to say, yep, I just received a 1, so I'm going to output a bang from this corresponding outlet. So now every time this is greater than 15, we're going to get that bang out of here, which is going to draw a new random value and create a new random note for us to hear. And that's pretty cool. Yeah, literally always, that the idea is that we are just, slowly adding more stuff to make this more interesting. Not necessarily more complex, but more rich for sure. And we're just playing new notes every time this is glitching out, which is pretty cool and fun effect. If we didn't want it to drone on, if we only wanted it to play when it's actually doing the thing, we just need to control the amplitude of the note, which we can do really easily using a multiply signal object, which is similar to your regular multiply object, except this is going to work on audio signal objects. Anything with a tilde, basically. That is how you denote audio signals in Max MSP, and we talked about that in the intro to audio video. So if we multiply our output of cycle by 0, as I have hard-coded in here, it's taking that sine wave line, that cool wavy line, and it is flattening it. So it is thin and flat, and that means you can't actually hear anything. If we multiply it by 1, we've talked about this, you get a return of the exact same values, because anything times 1 is the exact same value. So if we had this all the way up at 1, it would be multiplying that by that wave, which will then just return the wave, and we'll just hear the full audio signal sound, whatever it is. So if we want this to be more like note-like and not just drone on forever, we first have to assign the MIDI note. We have to tell this to turn up to 1 and then back down to 0. And that is where the line object that we've talked about is going to come in handy. We can just use some messages to set this up. We can say go from 0, and then we're going to put a comma to separate the message. So that first message is going to say start at 0, and then the second message is going to say go to 1 in however many milliseconds we define. Let's just start with 500 milliseconds. And that's going to be first. And then secondly, after we go up to 1, we need to then go from 1 back down to 0. So it's the inverse. And that will also take 500 milliseconds. And we'll just start there. And we need to make sure these things actually happen in the correct order. So again, here's where trigger object is going to come in handy. We're going to trigger a lot of things to happen. So we're going to create a trigger object with 3 B's in it, which stands for bang. So that way, when this threshold crosses and we get this bang, that means we did cross the motion threshold. If we patch that into the trigger, it's going to then output 3 bangs instead in order. So the first thing we want to happen is this. We want to create and play a new note. And that makes sense. We have to pick our new note first. The second thing we want to happen is then we want to increase the volume with our line object, and that will do such by being patched into there. And then the very last thing we want is after the volume increases, we want it to come back down. So we'll just draw our last bang out to this message box. And now that should work. We'll turn our audio all the way back up, and that's way glitchier. But now it is only actually playing notes when I am moving and it doesn't drone on. So again, maybe you like this aesthetic and this effect. Maybe you liked it when I was droning more. I don't know. Again, it's all up to you as the artist doing whatever you want to do. I'm just trying to show different ways we can make things actually happen with the objects that we've talked about so far, and how the potentials are truly endless. So with that, I think we can this is a good place to stop. We've talked about a lot of these intro objects. We talked about, needing jit.world to see things, video plane to host us stuff, and then all these fun jitter objects to kind of blend things together. We talked about this super cool technique to get motion value from like a live real-time video, whether it's the webcam or like you could use jit.movie and actually do this with just a movie file instead of the webcam. Totally fine. It's the same thing. You're just taking those motion values and then we're scaling that to change the dimension size, because why not? But it could literally change anything we wanted. We could have had it change this X-fade or maybe other effects. Who knows? And then we're taking that same motion value and we're just thresholding it, and we're saying if there's enough motion above this certain threshold, which we've talked about, this greater than equal to object in that video, we're gonna have that one turn into a bang using the cell object, and then we're gonna have that bang go out in a very specific order so we know that this is working exactly how we want it to work. And all it's doing is it's gonna pick a random MIDI note, turn it into a frequency value to drive our cycle, and then turn the amplitude of that cycle sine wave up and down so it sounds like an actual musical note. And that's it. It's, again, everything's really simple, and there's just so much more we can do just by mixing in different objects that we've talked about. Like this cycle doesn't have to be a cycle. It could be a saw or a rec, and we'll get different sine waves. I really want to leave that up to your experimentation, because that is the best way to honestly learn this stuff, is just to do it yourself. But I hope this video was helpful and gets you started in the right place to do some of that experimentation. And if you did find it helpful, as always, like and subscribe, because that lets me know I'm doing a good job. And honestly, there's a lot of people who are subscribed to me now, and I really appreciate that. Like, you have no idea what that means to me. So thank you again, everybody. Let's keep going, you know? Like, I'm not gonna stop. As long as you guys are learning, then that's the important thing. So on that, thank you so much. I hope everybody has a great rest of your day, and I will see you in the next video. Bye-bye.